part 3 here. So question number 6 that we were working on, pH of this guy, 0.0001 molar NaOH. Just like we've done before, you'd go from OH to the H, like we did in the problems in the first little video. And then from there you can just use pH equals negative log of the H. Number 7 is a theoretical question. You got to kind of know the acid and the salt to really answer it. But if I had equal molar concentrations of acid and equal molar concentrations of salt, I would expect that balance to give me a pH of a perfect 7. But again, there's a little bit more information needed there. Kind of a bad question. Okay, so number 8 says a phosphate buffer is prepared by adding 0.0602 moles of KH2PO4 and 0.00329 moles of its conjugate base or its salt K2HPO4. What is the pH of this phosphate buffer? I know that the pKa for the buffer is 7.2. So what this is asking me to use is what we call the Henderson-Hasselbalch equation, which is the pH is equal to the pKa plus the log of your base over your acid. Don't get this confused. If you flip that guy around, everything's going to be messed up. So I hate to be vulgar here, but the way I remember it is your ass is always on the bottom. So your acid is the one on the bottom. So in this problem, I simply need to plug in the value. So it's saying, what's the pH? Told me my pKa is 7.2. The log stays the same. And then I'm looking at the molar ratio of base to acid. So my base is 0.00329. And the moles of my acid are 0.0602. So really all I got to do is just solve that. 7.2 plus log, and we'll do that number first, although I could put all of this into my calculator at the same time. If I do decide to put it all into my calculator at the same time, I want to make sure that I put these in parentheses. Otherwise it won't like it. So I went ahead and solved that fraction first. It's 0.05465. So what I can do is just take the log of that, and it's saying, hey, this is negative 1.2624. So x is equal to 7.2 plus negative 1.2624. If I put that in my calculator, and I just like to save the answers that were already in there. So I took that answer, negative 1.264, and added it to 7.2. And I get a final answer of 5.9376, so on. And that would be the pH of my solution. Okay, I think we'll hurry and do another one so you can see that. Maybe sped up a little bit here. So pH of a buffer talks about my moles of NaHCO3 and Na2CO3. Because this guy has a hydrogen that can give it up, we're going to know that that is the acid. This one has more of that sodium, which is kind of letting me know that it is a base. So anyway, pKa, so X for pH, my pKa is 7.39. So always plus log, and then I've got to put my base, 0.125 moles of Na2CO3 over 0.100, which is the moles of my acid. So get out the trusty old calculator, and I'm going to do log, parentheses, 0.125 divided by 0.100. Obviously I didn't have to put the zeros in, but who cares. Hit enter, plus 7.39, enter again. My answer is 7.487. That's all there is to it. Finding pH of a buffer given the molar ratio of its base to its acid.